question like this one, then this one will follow this expression a power 0 is always equals to 1. So this means this one, we can make it 6 power 0. 6 power 0 shall be 1. So we can have this one a 6 power 0. So here I'll have 1 over 6 raised to power k plus 3 shall be equals to, say, this one I'll replace with 6 power 0. Okay. The other thing let me show us is that if you have this one is power 1 over 6 power 1 can be rewritten as 6 power negative 1. That means 6 power negative 1 is one and the same thing as 1 over 6 power 1. So this one you can say into k plus 3 shall be equals to 6 power 0. And so now with that, we can open these brackets, and this negative 1 goes with k. It also multiplies with 3. So we shall have 6 power negative 1 into k plus 3. Okay, that is the other mode of doing it, shall be equals to 6 power 0. And in that case, you can also say this is 6 power negative k plus negative k minus 3. So this is negative k, then this one is minus 3, shall be equals to 6 power 0. So now we can now consider only the indexes. So that means negative k, can do it here, that negative k minus 3 shall be equal to this 0 here. Negative k minus 3 equals 0. That in that case, we have a negative k should be equals to taking negative 3 to the other side becomes positive 3. So you can divide this by negative 1, divide this by negative 1, and you shall get your k to be a negative 3. That becomes our answer. Consequently, in the same way, we have another example here we wanted to attempt, and let me pick it. If we can have that example, 1 over 7 power m plus 9 equals to 1. All right, see how we can solve this one here. So this same one, we replace it with 1 power, a power 0 is 1. That means 7 power 0. Any number raised to power 0 gives us 1. So because I have 7, I can have 7 power 0 here. So I have 1 over 7 into m plus 9 equals to 7 power 0. And in such a case, we are having this one. I can replace now 1 over 7 in it, 7 power negative 1. Because this is 7 power 1. 1 over 7 power 1 can be written as 7 power negative 1 into m plus 9 equals to 7 power 0. So in such a case now, can move on to see how we solve this one here. This will be 7 into negative 1. Negative 1 is going with m plus 9, shall be equals to 7 power 0. So this one be 7 into negative m minus 9 equals to 7 into 0. Wonderful. And then now we can pick up the indices. Minus 9 minus m minus 9 equals to 0. So taking 9 the other side shall be negative m, giving me positive 9. When negative 9 crosses the equal sign, it becomes positive 9. So with this one, I can divide by negative 1, divide by negative 1, and I will have positive m here. And now, because this is a positive and a negative, I'll have this as negative 9 as my answer. M becomes negative 9. Now, there is also the second method, which is also equally important for us to see. We shall solve these questions using the second wonderful method, and that is now using the logarithm. Now, using the logarithm, with this one, so the second method now is solving this question as we've seen. Let's do it practically and see how we can even get to our answer. You introduce logs both sides, is an log and here log. So you shall have log 1 over 6 into k plus 3, power k plus 3 equals to log 1. Now, log 1 usually equals to 0. So you shall have, this is log 1 over 6 power k plus 3 equals to 0. And again, this power here comes here. So this power here shall be brought here. So we shall have k plus 3 times log 1 over 6 equals to 0. Yeah. So this is also, they say, the law of logarithm, which brings us to this is when you have any log a power b shall be equivalent to b log a. So this power here is brought here. So this here. So when we have this here, we have to bring it down here, which we have done. Now from here, we can open our brackets. So we are having, we shall have this as, okay, this is k times this one. We shall have k log 1 over 6 plus 3 log 1 over 6 equals to 0. Mhm. So now we can now pick this one and move it to the other end. This shall be k log 1 over 6 equals to negative 3 log 1 over 6. Yep. So we just took it to the other end. Now, after we have done that, we shall divide both sides by log 1 over 6. So this one gives us, divide this by log 1 over 6, and this other divide by log 1 over 6. And so this one goes, we remain k to be equal to, and this one goes, we get to be negative 3. So that is that. I think that now makes it clear. From this, the solution to number 2 using the logarithm method is replace this one with a 0 because log 1 is 0. And then now pick this power here, bring it to the other end, which is that you have done here, and you get log 1 over log k plus 3 log 1 over 6 gives us 0. And then open the brackets, and then pick this, bring it the other end, and then you will have to divide by log 1 over 6 both sides, and you'll get to this answer. We can also try solving the third example which we have done, which was this one, was our number 3, which was 1 over 7. Okay, let's say number 3, yeah, 1 over 7 into m plus 9 to be equals to 1. Let us work it out and see. The same case here, we shall introduce logarithms. You have log 1 over 7 m plus 9 to be equals to log 1. So we say this will be m plus 9, okay, log 1 over 7, good, okay, equals to 0 because log 1 is 0. It's good. Now from there, you open this bracket, shall have m log 1 over 7 plus 9 log 1 over 7 equals to 0. Now this one taken to the other end shall be m log 1 over 7 equals to negative 9 log 1 over 7. So we say that at this point, you divide both sides by log 1 over 7 plus 1 over 7. So I divide by log 1 over 7, divide this one by log 1 over 7. So this one, I'm getting it to be m equals to negative 9 because get negative 9 is the answer. So that's it, yes. I believe now this one makes it clear to everyone.